Okay, we're going to start 12.7. This one's going to be really short. We're going to restrict ourselves to dividing polynomials of a special type. In particular, the numerator. Let's just remind you of something. So, if I have a polynomial, and many times we'll represent polynomials by p in parentheses x, divided by another polynomial, qx, then the result is always going to be another polynomial mx plus some remainder. And that remainder may or may not be a polynomial. So let's just remind you of some just simple division here. Go back over here. And let's look at just division by number, something really simple, like maybe 25 divided by 7. Well, 25 divided by 7 is equal to 3 times 7 plus 4, where 4 is our remainder. So we're going to be doing the same thing. We're going to be dividing polynomials by other polynomials, and let me get so the result of your division is called your quotient. The dividend is the thing that is being divided, and the thing that divides the dividend is called the divisor. I really don't like these terms. The only term in this group that I really employ myself is the quotient. And just remember, the quotient is the result of division. And I like to call what's on top the numerator and what's on bottom the denominator. But those are some other terms that you might very well see in the lesson. So here is the deal. I don't need the erase. You already know one thing about adding fractions. If I want to add a over c plus b over c, what do I need? I need a common denominator. And usually I want to find the least common denominator. But when I have the common denominator, all I have to do is the result in fractional terms is the result is over c, which is my common denominator, and then I just add a plus b in the top. So we have been, up until now, trying to find our common denominator and write fractions in the form of AC plus BC. And then once we have that common denominator, it's easy to find the result of the division. Now we're going to be doing the exact opposite. And thankfully for this class, the exact opposite is going to be really simple. We're going to be given A plus B divided by C, and what we want to produce is AC plus BC. So we'll just do a few exercises. There's not too many problems related to this, but it will be helpful to know, and we actually take polynomial division to its full developed conclusion in intermediate algebra, as long as we're talking about polynomials in a single variable. And we don't do multi-variable polynomial division, which brings about its own challenges, which are interesting, the way they're solved, the ways they can be solved. So 1a, we are given 10x to the 6th minus 40x cubed. So that is the sum in our numerator, all of which is being divided by a monomial. And all we're going to do in this course is division by monomials. So by the rule, I take the first term in my numerator, 10x raised to the 6th, and I divide it by my denominator. Then, since this is a minus sign, I'll write a minus, and 40x cubed divided by my denominator. But in this case, each of these terms can be simplified. So 10x to the 6th divided by 5x squared is 10 divided by 5, which is 2, and x to the 6th divided by x squared is x to the 6 minus 2, which is x to the 4th. Now 40 divided by 5 is 8, and x cubed divided by x squared is x. So I actually get a polynomial. You don't always get a polynomial, but that time I did. Now let's do 1b. You may actually always get a polynomial in the examples I give you here. That's not generally the case, but as you well know, in this class, we give you the start of everything. And then in later classes, we push each one of those topics into more and more depth. And sometimes introduce new ones. So the result of this division will not be a polynomial. I just answered my question. So again, all I do is I split the terms up. A plus B over C is equal to AC plus BC. And that's basically the rule I use. So 10a to the 5th divided by minus 2a to the 7th. This won't be a polynomial. It'll be a polynomial with remainder. So 6 divided by minus 2 is minus 3. A to the 7th divided by a to the 7th is 1. So I already have a constant term. So here's going to be my remainder. 10 minus 10. So this is, remember, I can do one of two things. Minus 10a to the 5th over minus 2a to the 7th, where this minus is in line with the division sign. I can either put it up there so that I'm dividing minus 10 divided by minus 2, or alternately, I can put it down here. In either case, a negative times a negative is a positive, so this is the same as minus 10 divided by minus 2, which is positive 5. Notice the sign change. A to the 5th over a to the 7th is a to the 5 minus 7. So simplified, this is minus 3 plus 5. We want our variables, our exponents, to be positive. And to make a to the minus 2 positive, I put it on the other side of the division line. And that's our final result. Notice this is not a polynomial. It's a constant term plus another constant term times a variable raised to the second power. In polynomials, all exponents are positive. So that's not a polynomial. We like it when the result is a polynomial. That makes it really, really nice. What would that be like in, in regular? Let's do this. 25 divided by 7 is 3 with remainder 3 4/7, which is the same as 3 plus 4/7. So in this case, we didn't get a whole number. We divided a whole number by another whole number, but our answer was a whole number and a fractional part. Had I divided 21 divided by 7, the answer would be 3 plus 0/7, which is the same as 3. So sometimes, just like in division by whole numbers, you can divide a whole number by another whole number. You'll get some other integer plus a fractional part, or you'll get an integer plus a 0 fractional part. So this is the case of like dividing a polynomial, buying a polynomial, getting another polynomial. This is the case of dividing a polynomial by a polynomial, getting a polynomial plus something else that isn't a polynomial, just for what it's worth. So let's do number C. So these are really simple. So minus 14 x to the 7th plus 6 x to the 6th minus 6 x to the 5th divided by minus 2 x to the 5th. So this will turn out to be a polynomial. So the first is minus 14 x to the 7th divided by minus 2 x to the 5th plus 6 x to the 6th divided by minus 2 x to the 5th, and then minus 6 x to the 5th divided by minus 2 x to the 5th. So let's simplify. Minus 14 divided by minus 2 is positive 7. X to the 7th divided by x to the 5th is x to the 7 minus 5, which is x squared. 6 divided by minus 3, 6 divided by minus 2 is minus 3. X to the 6th divided by x to the 5th is x. So you have two options. You can do plus minus 3x, or you could write 7x squared minus 3x. I like the bottom. Minus 6 divided by minus 2 is plus 3. X to the 5th divided by x to the 5th is 1. So this is the result, and it is indeed a polynomial. In higher math, there's a whole branch of math dealing with this type of observations. That sometimes you divide a polynomial by another polynomial, and you get a polynomial, and sometimes you don't. And the guiding factor, if you look up here, if you look at the degree of the monomial, if that degree is larger than the degree of the smallest, any of the degrees in the upper polynomial, then you're not going to get a polynomial as a result. It doesn't matter, all of that stuff I just said, you're not going to be tested on it. It's just going to do one more example. This is going to be a short, that's one of the reasons I'm kind of talking about a lot of things, because it is important in another context. Of course, one that you'll probably never deal with. So this is an in-class practice, and I'm only going to do one of them. These are so simple that I'm not going to belabor it, and you'll probably be appreciative not to have a long lecture to listen to. 16a cubed minus 12a plus 6. So again, this won't be a polynomial when I divide it, because 4a has degree 1, which is larger than the degree of the constant term, which has degree 0. Whatever it's worth, that's the same as 16a cubed divided by 4a minus 12a divided by 4a plus 6 divided by 4a. Well, 16 divided by 4 is 4. A cubed divided by a is a to the 3 minus 1. 3 minus 1 is 2. Minus 12 divided by 4 is minus 3. A divided by a is 1. And all I have to do here is simplify 6/4. They are both divisible by 2. 6 divided by 2 is 3. 4 divided by 2 is 2. And the a goes in the bottom. And there you have it. And that's all we're going to do with dividing polynomials.